Thank you all for joining us for our SICSS-Howard Mathematica guest lecture with Dr. Shawndra Hill. I will begin by introducing our speaker. We'll close with a few resources that will help you get to know SICSS-Howard Mathematica if you are joining us for the first time. Our speaker. Dr. Shawndra Hill joined the marketing division at Columbia Business School as a part-time senior lecturer in September 2020. She received her Ph.D. and MPhil in information systems from NYU's Stern School of Business in 2007 and 2003, respectively, and her BS in mathematics from Spelman College, and her BEE in electrical engineering from Georgia Institute of Technology in 1995. Presently, Shawndra Hill is also a principal scientist and manager in tech. Prior to joining industry, she was a professor in the Operations and Information Management Department at the Wharton School of the University of Pennsylvania. Broadly, she studies data mining, machine learning, and statistical relational learning and their alignment with business problems. Specifically, she researches the value to companies of mining data on how consumers interact with each other on online platforms for targeting media, advertising, health and fraud detection purposes, etc. Her current research focuses on cross-channel advertising and the resulting interactions between TV content and online ad click behaviors. Welcome, Dr. Hill. The floor is yours.
Great. Hi, everyone. I'm excited about this invitation, and I'm happy to be here to talk about data science for marketing. The way that I've organized this talk is really to give you a high-level overview of the type of work that I've been doing at the intersection of data science and marketing. And it's by no means comprehensive, but I think the projects will give you a good idea of how data science tools and techniques can be used in the marketing space. I'm going to start off with one of the very first projects that I did in marketing back in 2004. And in 2004, there weren't a lot of kind of social networking sites, or at least they weren't as popular as they are today back then. So it might be surprising that back in 2004, there wasn't a lot of work using real world social network data in business. And so what we did or tried to do for marketing was try to capitalize on the fact that there's meaning and information in the fact that certain people interact. So when I talk about social network data, I mean data where there are nodes or some representation of a person on a network, and then the connections between them. And oftentimes those are called links or edges in the literature. And so in the case of the projects that I worked on very early on, we were working in telecom networks where the nodes or actors were people and the links or edges between them were phone calls. So people were connected because they made phone calls with one another. And these data have been, kind of shown to be useful in various contexts. For instance, there's this notion of homophily, where the idea is that birds of a feather flock together. And if you kind of know some information about your friends, for instance, their age, it could be very predictive of what your age is. And this notion of homophily sort of takes two flavors, right? So one is just that you tend to kind of connect with people like you along the lines of demographics. It could also be that, you belong to a certain group, for instance, a soccer team, and, then as a result, you guys have certain knowledge or information about that group and sort of how the group interacts. These networks could also be useful because they can indicate where and how certain types of information might be shared. So in the case of marketing, if I see, for instance, that people on a network are more likely to know about a particular product or respond to an ad, it could be because this group is all similar, but it could also be because people who've already adopted the product are sharing that information with their friends, and therefore people are just more aware, not because of marketing, but because of word of mouth. So with the work that we did early on, we didn't aim to kind of tease out what was happening on the network for marketing, meaning, it could have been that people were spreading information about word of mouth. It could have been that birds of a feather flock together. For us, it didn't really matter. Like, what we were aiming to do is try to find value in these networks for predictive purposes. And so what I mean by that is we had a very simple problem. We wanted to target market a new service to potential customers. And what we did was we took the list of existing customers of that service, and we then asked, who are their friends, right? And in this case, again, these friends or connections were really asking sort of, who do these people call and who calls them? So we called these people that were connected to existing customers through phone calls network neighbors. And we asked, could this information, the fact that we knew that these network neighbors were connected to people who already had this particular phone service, could this help us in predicting whether they would be more likely or not to buy the service themselves? So in our case, we were simply adding features that we constructed from the network. In this case, were you connected at all to an existing customer, or how many people were you connected, after controlling for demographics, and then asking, does this additional data improve our ability to rank these customers by their likelihood to adopt the product? And the answer is yes, or probably I wouldn't be talking about it, at least in this particular context. So in this particular context, the network neighbors were up to 5 times more likely to purchase the product than people who looked like them, but were not connected to existing customers. And so this work, it might be a surprise to you now, again, because there's so much network data, social network data in particular, out there, oftentimes for free. But this was kind of some of the first work, or some of the first work that connected social network data to marketing outcomes. So real dependent variable, did they buy this particular product or not? And so as a result, a lot of researchers, companies, in part as a result, also people were starting to work on this in parallel because more social network data were coming online. There were a number of companies that kind of were established, startups that were established to do what was called social network-based advertising, where they were simply trying to, construct features from the user's social graph in some ways to predict whether somebody would click on particular ads or not. And so as a researcher, I was pretty uncomfortable with the fact that people would cite our work and be like, yeah, social network-based targeting works, right? Because in our case, we showed that it worked in the telecom context for a particular product, but we didn't show more broadly for a wide range of products that social network-based targeting would work, nor did we fully understand, what type of network would you need to, define these kind of relationships or patterns. So in our case, we were using phone calls, and so people were connected by these phone calls, but people were using data like Twitter data, where people were connected because they followed people on Twitter, or Facebook data where people were connected because they friended, and we didn't know if those networks were as valuable or useful. So one of the things that we tried to do next is try to understand when social network-based targeting would work. And the way that we did that was we utilized Twitter data that we could collect for free at the time, unlike the data that I just mentioned. So the telecom data had to be sort of internal to the company to get access to that data. But with Twitter data through an API, I was able to put in Twitter handles of TV shows and brands, and then for those TV shows and brands, collect all of their followers, and for those followers, get their followers, and then also for all of these users, get all of the text that they had posted as users to Twitter. And so the idea here was to understand to use this data for various reasons, including to understand how social network data for prediction in this particular context, which would be recommending Twitter handles to users, how using social network data would compare to doing something more common, which is to use, let's call it the product network, like the fact that people follow similar products, right? So looking at co-occurrence of following the product. So we called that the product network recommendation engine, and we compared it to what would happen if we used people's friends. So for any given user, we asked what proportion of their friends followed a particular brand or product, and we used that to rank the products they would likely follow. And so this plot, it's complicated, but I'm going to give you the punchline. On the horizontal axis, it's the number of recommendations that each of these different recommendation engines that we built on top of Twitter data made. So in the product network, we were making recommendations based on the product network, and we ranked those recommendations from kind of 1 to 200 in this plot. And on the vertical axis, it's comparing the performance of the product network based approach to the social network based approach. And so what we found is that the social network based approach, so targeting or making recommendations based on what your friends follow, works better in context where the brand or product has a skew, like a niche audience, right? So some skew to some demographic, versus the product network tended to do better for products where there were more ubiquitous. And so what this plot is showing is the difference in performance, where on the bottom half of this plot, when the difference is less than 1 or less than 0, sorry, the social network based approach did better. And when the results are above 0, the product network did better. So this was some of the first work that tried to get at, for which types of products, for which types of brands should we expect the social network-based approach to not only do better, but also the paper talks too about adding value. So these data from Twitter were quite valuable because they were free, right? And so we can sort of get insights like this. In addition to the social network data, we also looked at the text of the users that followed a particular brand. So what we did was we basically created, let's call it a document that represented every single brand or TV show in our study. And we correlated the text in the documents that we created with attributes about the audiences of those brands or TV shows. And the way that we got the data on the audiences was through data that you could purchase, data from ComScore that we could purchase to get a sense for who purchased these brands. And then also we use the Facebook targeting solution to understand who was following these different brands on Facebook. And so we connected the proportion of people that were in the audience of a particular brand, of a particular demographic, to these words. So for instance, if we looked at the audiences of all of the brands and asked what proportion of the people who purchase or follow this brand are women, we have a score, a proportion of women for each of these different brands. And so there's some brands who have a very high proportion of women who are the audience, and some brands that skew towards men being the people who are more likely to purchase. And so we use these proportions as, let's call it like a dependent variable, but we use them to correlate the attributes of the text. And so what we were able to see is that there were words that were correlated with different demographic categories. For instance, audiences that skewed female or male or young or old. And so we got things like audiences that skewed female were very correlated with words like love and beautiful and cute at the time. And products that skewed male were seeing words that popped up like game and league and Hulk and battlefield. So these gave us insights about the types of things that people say in certain groups. And also we could then use these conversations to calculate the similarity between different brand and product audiences. And so we did that also and built a recommendation engine based on the text. So these are data that, again, were free. They're still free. I think, the limits on these APIs change over time. But there's a lot you can do in terms of understanding audiences, utilizing tools that are available for free. After doing a lot of work using social network data, I joined a research lab and started focusing on questions related to search engine advertising. So here's an example that's quite different from those that I kind of went over before, in that in this case, we ran an experiment, right? So in the examples that I mentioned before, we were using primarily observational data, which means that these are data that are being collected as part of our daily lives, and they're just kind of laying around without at least knowledge of an experiment being run on these users. And in the past, usually we were using those data in sort of the research projects that I did to make predictions about users, right? So either would they buy something, are they fraudulent, using them to sort of rank products by the likelihood that you would follow them or buy them in the recommendation engine context. And in this case, instead, we're running an experiment in a search engine. So what we wanted to understand is when somebody goes to a search engine and types in what we call a focal brand, so the brand that, for all intents and purposes, they went there to find information about, what happens when competitors show up and bid on the focal brand's keywords, right? And so this is an interesting and important question, because prior work had found that, or claimed that, there's really no value in search engine advertising. But the focus there was really on cases, for the most part, where when you search, you see the focal brand's link in an ad, and then right below it, you also see the organic content, and there's a link to the product page. So it's like, if you're only going to see these things back to back, the users would likely get to your product page anyway, right? But more and more, advertisers are trying to steal traffic from their competitors by bidding on their competitors' keywords, right? So in this case, a user was searching for Edmunds, and Edmunds, in fact, shows up at the top still, but you see that the Kelley Blue Book company was also bidding on Edmunds and showed up right below it before the organic search results showed up, right? And so the question we wanted to know, or the answer to, is whether the fact that competitors were bidding on the focal brand's keywords led to stealing of traffic, right? And also, if so, how big of a problem was that? So the experiment was quite simple. We manipulated two things, both the order in which ads were shown and whether ads were shown at all, right? So we first took all of the ads that were available and shuffled them. So what that means is Edmonds, in this example, could show up further down the page, right? And so that's actually unlikely to happen in the real world. Usually the brand or product that somebody is searching for, if they put a keyword in associated with the brand or product, a specific keyword, the most relevant thing of the highest value would be to the user in terms of, sort of matching intent, would be the focal brand's ad, right? So it's rare that you would see a competitor show up at the top. So randomly shuffling these enabled us to ask, well, what happens if a competitor showed up at the top? But not only that, we were also able to sort of ask what happens if a competitor shows up at all. So the advertiser links were shuffled at random. And then also the number of ads that we showed was shuffled. So either we showed 0, which is not show ads at all. We showed 1, 2, 3, 4. So 0 to 4 ads. And so what we learned from these data are that, in fact, competitors could steal traffic, and they were more likely to steal traffic if they were similar in terms of sort of their market position to the focal brand. So this experiment enabled us to answer those questions, but I wanted to point out that unlike the work done with Twitter data, this kind of required that you be on the inside, right? And had the ability to kind of run an experiment on the platform itself. So if this type of work is interesting to you from a data science perspective, it probably makes sense to, sort of aim to be on the inside to run experiments like this. I spent a lot of time on search data, just kind of, looking at experiments like the one that I mentioned, but also looking at observational data motivated by this picture, right? So the idea is that we're oftentimes sitting in front of a large screen, for instance, a TV screen, watching videos or linear TV, and we see ads. And when we see those ads, we sometimes take action to get more information or to go to the website and buy something about the products that are being advertised, or even sometimes their competitors. So I spent a lot of time looking at this interplay between triggers that are happening on one screen and how that translates into what people do online. So the idea here is that a person would see a TV ad, then they open up a search engine like Bing, and then they search for the product. And when they search for the product, they get both the organic links and also ads about that product. And we can ask, not only who are these people, but what are they doing when they search after a TV ad? So these are mostly projects about aggregate level data. So we know a TV ad on linear TV was shown at a particular location at a particular time. And we can ask then, what happens right before the ad was shown and what happens after the ad was shown? So we weren't the first to show that there are search spikes after TV ads were shown. So here, this is showing on the horizontal axis, minutes before and after an ad, where the negative minutes are sort of, 1 minute before, 2 minutes before, 3 minutes before, and the positive minutes are what happens in the minutes after TV ads are shown. And we found search spikes for products, just like prior work had found, but we were able to sort of ask deeper questions about who these users are with respect to, are these people that are coming to learn about the product for the first time, or are they, kind of repetitive searchers of the same brand, or, what does the composition look like with respect to the types of devices they searched for, or the the types of the people they are with respect to demographics. In addition, after we started that work and began to understand sort of when these search spikes happen, we also took on projects to understand the longer term impact of these search spikes. So here it's about the minutes after, and then we started to connect users to themselves with sort of individual level household data. So we can ask not only what happens in the minutes after, but when a TV ad is shown, what happens over time. And so in this plot, on the horizontal axis, you have for a particular brand, how likely is it to be purchased online? And on the vertical axis, we have, does this brand require search? And these values per brand are based on survey data that we asked users regarding the brands and products that you see in this slide. And so what we found was the bigger the triangle, sort of the more significant the effect. We found that for brands that are more likely to be purchased online and more likely to be require search, we saw like more sustained and bigger search spikes for those brands in the minutes and in the long term after those ads. And so this is new work that we're still working on, but the goal there was to kind of look at the long-term effect of the impact of TV ads on search. In addition to thinking about TV ad triggers, we also tried to understand kind of how people search in general about the content that they are seeing on TV. So here's an example from the Super Bowl, where on the horizontal here, we also have time, and the vertical axis is hidden just to kind of not reveal how many searches there were on Bing at the time, are the number of searches in that particular hour, I believe, right? So you see that, kind of when the Super Bowl was on, you get the most searches, then it dies out, and you kind of see this pattern also of when people were going to sleep, right? Like, so this dies down and kind of goes back up the next day, probably when people started talking about the Super Bowl and what happened the day before. So we could also see, how these patterns change in terms of the proportion of people searching from mobile versus PC. So during the Super Bowl, maybe they were outside of their home and searching more on their mobile device, but then the next day there were more searches. Maybe people were at work and kind of searching from their PC to see how, what people were saying, or maybe the people who didn't see it, were kind of searching. But in any case, the searches kind of reveal the patterns of attention to the Super Bowl at that time. And so one thing we wanted to understand was, do people search for different things? And not only do they search for different things over time, do they click on different things? Because if they click on different things as it relates to the content that they're seeing or the context that they're in, for instance, pre-Super Bowl, during, or after, that suggests potentially like a different ranking of the search engine results if they're not factoring in that information. So on this slide, what we're showing is that for the same query, Super Bowl, people were more or less likely to click on different things. So same query, so it's typing in Super Bowl, and the green is what happens 24 hours before, the blue is during the game, and the yellow is 24 hours after. So you see that for things like just searching for Super Bowl 50, which was Super Bowl 50, people were more likely to kind of click on that link 24 hours before versus kind of looking for who the champions were. You see the yellow bar is longer, and they're looking 24 hours after. And if you look down to number 10, they're more likely to sort of click on the watch live stream online for free during the game, right? And so these patterns make sense, but again, like people typed in the same search query and wanted different things after they searched for Super Bowl, depending upon whether it was before, during, or after the game. So we took the snippets. So the snippets are what show up below the link when you pose a search, right? So like in the organic traffic. And we basically generated topics based on the search snippets of the links, because the links don't have that much information. And from these topics, we asked, could we build a model, a dynamic model that factors in both like what people were searching for, the content that showed up in these snippets, and the feedback, so the clicks on these different links. And so it turned out that we could build a model over all these data to predict what people would likely click at a particular time better, right? And so I'm using the Super Bowl as an example, but we did this for many, many TV shows. Okay, so that's kind of where I'm going to stop with some of the search results and kind of move to the last project, which was one that was motivated by the fact that we saw people were, or advertisers were aiming to be more inclusive in their advertising. And we wanted to understand ultimately, so this is just kind of talking about like step one, which is like understanding who is being more inclusive. Ultimately, we wanted to connect these inclusivity scores to business value, right? So is there business value in terms of, kind of revenue and those types of things, instead of, looking at it from the perspective of being the right thing to do? Is there business value of being inclusive in advertising? So in order to do that, we needed to know like who, with respect to the advertisers, were actually being inclusive, because there's no, spreadsheet or data set that gets at this. And so the way that we did this, so we scored advertisers and videos based on how inclusive they are. The way that we did this was we started with the videos of many, many different advertisements, right? And so I want to contrast this particular project with the others that I've talked about so far, in saying that, basically we're utilizing off-the-shelf techniques to extract meaning from different data, right? In this case, from video. And so the world of techniques has kind of exploded, and solutions have, been democratized, for better or worse, right? Like, so we all have to use these tools with care, but we were not, computer vision experts, but could use off-the-shelf tools that were available for free at the time from Microsoft to extract features from these videos. So in the other cases, we're either building features ourselves, using, research as a motivator for what should work, or we're running experiments. In this case, we're mostly like using off-the-shelf tools to help us kind of summarize data, so to get features to summarize data. So the way that this works was we took the video and we ran it through a tool that was called Video Indexer at the time. And the Video Indexer extracted the images of the people in the videos, and also information about the video, like the script and other things, right? And so we then sort of took the images that it extracted of the people in the video and ran them through the Face API. That gave us some estimate of the age of the user and the gender. And then finally, we used the face API again to deduplicate any of the faces that were extracted that were the same, right? So we wanted to count the people in the images and then try to understand, was this a diverse set of people with respect to gender, age, and race. So by now we've learned that a lot of these solutions don't always work perfectly. And certainly there's variance across different types of people in terms of their performance. And so what we did was we combined data that we were getting from the tools that were kind of extracting things automatically with survey results from users on Amazon Mechanical Turk. So Amazon Mechanical Turk is a solution that you can use when you need human labelers. So you can pay human labelers on Amazon Mechanical Turk to label things like text or images for you. So in this case, we took all of the images of people that were extracted from the videos, and we asked users, first of all, was this a person? And then we asked what they thought the person's gender was, what they thought their age was, and what they thought the race was. And if I remember correctly, we tried to marry the categories with what we would get from Nielsen. Like, so we mapped on the age categories, I believe, to sort of the Nielsen categories. And then the exit survey kind of asked the person who was answering the question what their gender was, if they were willing to answer, what their age was, and how hard this task was of labeling people's gender, age, and race. So we took that data, and just to give you a sense for how much this cost a few years ago, we took all the national ad impressions from November to December 2017, which resulted in about 400K unique TV airings. So this is kind of national in the United States in that time period. And it resulted in, right, so most ads are shown multiple times. So it resulted in 8,067 videos, 6,098 of them had people in them, and about 46,000 images before the deduplication process. And so we took all those pictures and asked these Amazon Mechanical Turkers to label them. And this cost us about on the order of like $5,000 to do this. So we got 2 labelers for each image. And so what was interesting is that the labelers didn't always agree on gender, age, and race. So there was 87.5% agreement on both women and men. So basically this is just comparing rater 1 versus rater 2 on what they said, whether it was unclear female or male for these images. And you see that on the diagonal where they agreed, like, sort of more often it's the case that the 2 users agreed in this case. For race, there was 69% agreement on whites, 61% agreement on Blacks, less than 10% on Hispanics, and less than 15% on Asians. Now, let's be clear, we have no ground truth, right? This is just assessing whether 2 independent raters agree on what the age, gender, and race of the users in the images are. So these labels, regardless of if they're sort of inferred ultimately by a model or by users, without knowing the ground truth, are going to certainly be noisy. So how did we use that data? We created a dashboard where we took these 3 dimensions, age, gender, and race, and came up with an overall diversity score at different levels of aggregation. So at this top level, we had the particular industry. So you can see apparel, footwear, business and legal, education. And then we had clicked into, on the second row, a specific brand. And then for that brand, you can click onto different products. And then finally, at the bottom, it sort of listed out all of the different ads if you wanted to dig down, right? And so the idea behind this was just for ourselves to get a sense for which industries are more inclusive, which aren't, whether we could do this to begin with, like so score brands on how inclusive they were. And then ultimately, as you mentioned, the ultimate goal was to kind of link these inclusivity scores to business value in the end. So just some high level kind of insights from these data that we collected and aggregated. Maybe not surprising, we found that women were more likely to be shown in retail stores and health and beauty, less likely to be shown in electronics and communications and vehicles. Blacks were more likely to be shown in ads about politics, government, and organizations and education, less likely to be shown in home and real estate and health and beauty. Seniors were more likely to be shown in insurance and pharma, and less likely to be shown in apparel and footwear. So in this case, like, we're not passing any judgment on these industries, right? Like, so some industries might argue that, you know, that's their target demographic, and so that's who they include in their messaging or in their ads. What we wanted to understand is just, could we, you know, sort of come up with these scores and then again ultimately link them to business value. However, you know, based on these relationships, right, between the different categories and who shows up in the ads, it does give us insights into how these different advertisers and industries kind of go about advertising to users. And so this summary is something that, you know, really didn't exist anywhere else. And so this was kind of a first step in a larger agenda. So this is the last project that I'm going to share with you. I've done many more, but I wanted to give you a flavor of the types of things that could be done in, you know, sort of what we're broadly calling marketing, but it's really like MarTech, ad tech. And really, it's, you know, sort of starting with a question that you want to understand about users or audiences or how they respond to marketing messages, and then asking sort of what data are out there that can help you answer these questions. And of course, you know, many of the things that I've showed you, with the exception of when we ran experiments, are not necessarily causal in nature, right? And so really, like, we oftentimes show that certain types of features or certain types of information can be generalizable to the extent that, you know, repeatedly, like, we can predict outcomes of users, but we're not making a lot of causal claims. In fact, you know, kind of advertising is one of the places where it's really difficult to attribute behavior, specifically, you know, purchases and those things, to you know, the triggers that are constantly being kind of thrown at us. But all that said, it's a really exciting space to be in. I don't think there are tons of people, you know, sort of getting degrees in computational social science that think about, you know, kind of pursuing marketing as an area for data science or computational social science. So hopefully this gave you a flavor of things that could be done, and, you know, helps you to think about some of the opportunities that might be out there in industry and academia as well. So I'll end there, and also just let you know that for most of the things, almost all of them that I showed, there are papers, research papers that are usually quite long. So I didn't want to bore you with the details, but if you are interested in the work that kind of backs up what I showed, just simply kind of go to Google Scholar and search for me, and you'll find a bunch of papers that you can sort of begin to dig into to learn about how we've applied data science to different marketing applications. So I'll end there, and I look forward to kind of talking to you about these things and to your questions. Thanks.
Thank you for joining us, Shawndra. It's always great to share space with another person from Nassau County. I'm still in awe of the fact that we grew up in the same town. I know our participants are going to enjoy spending time with you as much as I have. I know they're looking forward to live Q&A with you during the Institute in June. Thanks again for joining us. Thank you all for watching. For more information on SICSS-Howard Mathematica, visit our website, follow us on social media, and join our email list.